Okay, hello everyone. As we say in analyzing data, there are two important measures. The first one is the centrality measure, which we dealt with in the previous lecture. We said that we have mean, the arithmetic mean, the median, and the mode. Okay. Now we have the dispersion measures, which are the dispersion, the scatter of the data around the mean. One type of dispersion measure is the sample is the range. Okay, is the range. So, and please recall that we always deal with populations, but it is very hard to collect all of the data regarding the population. What we do is we take a small sample. So, for example, if we are dealing with the height of students in the university, it's very hard to measure the height of all of people, all of the students in the university. So, what we do is we just take a small sample. Okay. So the range of the sample is called the sample range. So what is a range? Well, simply what you do is you just take the maximum and subtract the minimum of the data from the maximum. Okay. So this data is, assume you have a data of 5 units, 5 observations, sorry. So you have 180 here, 192, and so on and so forth. So you just order them and take the difference between the smallest and the largest, which is equal to 25. So this is the sample range. Okay. And another measure is the sample variance, which is defined as this equation. Okay. So another form of the equation is this one. This is easier to calculate if you are calculating with your hands. Okay. Also, it's easier to calculate in Excel as well. But this is the definition of the sample variance. Please let's look at this definition. So remember, we say that we have two important measures. One is the centrality, and the second one is how much data is scattered around the center. Okay, so what is the difference between the data and the center? So let's look at this. Sorry, let's look at this. Please look at this definition. So in fact, this is equal to xi minus x bar, okay, squared divided by n minus 1. Let's try to see what does this mean. So x bar, what is the x bar? X bar is the mean, okay, that's the arithmetic mean, or we are talking, if you're talking about the sample, that's the sample mean, okay? So x bar is the sample mean. Um, so what I'm trying to do is find the difference between your observed data and the average, okay, the mean. Okay, so mean is the average of the data, right? Between your observation and the average. So for example, let's say I have a data of, let's say 2, 4, 6, 8, and 10. So what is the average of this? The average of this is equal to that's equal to 2 plus 4 plus dot 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 10. Okay, divided by what? Divided by 5. Um, so that's equal to 6. So the average of this data is equal to 6. Okay. So what I will do is I will try to find the deviation around the center. So let's say this is my first data, 4, 6, 8, and 10. Now I will, so this is xi. Let's try to find xi minus x bar. 2 minus 6, that's equal to minus 4. 4 minus 6, that's equal to minus 2. 6 minus 6, that's 0. 8 minus 6, that's equal to 2. 10 minus 6, that's equal to 4. So let's find the total deviation. What is the total deviation? Minus 4 minus 2, 4. Well, that's equal to 0. Okay. Well, I don't want this, right? That's not that's useless. So what I need is I need to find the deviation um, so that I can use it. I cannot use this. So what we do is, in order to get rid of the minus values, we just what? We square them. We square them, right? Minus 4, square of minus 4 is 16. Minus 2 square is 4. This is 0, 4, and 16. If you sum them up, this is equal to 20, 20, that's equal to 40, right? That's great. That's equal to 40. So 40 is equal to what? 40 is equal to xi minus x bar. You take the square and sum them up from 1 to 5. Okay, that's equal to 40. So what is this? This is the total deviation. This is the total deviation of data from the center. Okay. What I need is I need the deviation per unit. Okay, the deviation per unit. So what you should do is you should just divide it by how many units we have. We have 5 units. So you should just divide it by 5. But this is not 5. Um, so if we have time, we can just cover this, but due to the properties of the estimators, we will talk about it later. We will not divide it exactly by 5, but just reduce it by 1. So we will divide it by n minus 1. Okay, that's why we have it here. We will divide it by 4. So that's equal to 10, right? That's equal to 10. So that's equal to 10. 10 is the variance. That's the sample variance. That's the variance of the sample. Okay. So again, what is this? This is the total squared deviation around the center, right? So what I can do or what I should do is um, take the square root of this, okay, which we will call S, that's equal to square root of 10. And that's what we call a standard deviation. Okay, that's the sample standard deviation. So what does this mean? Square root of 10, which is, I don't know, but there's something 3.3. I'm not sure whether that's true or not. But what does this mean? This says that on the average, on the average, your data here, your data here, um, is 3.3 units away from the center. Okay. On the average, your data is 3.3 units away from the center. Okay. So how to calculate the standard deviation for a now frequency series? Okay, so let's try to find the standard deviation in frequency series, right? So this is the data of daily consumption of flour in a bakery. So it's given as a frequency series. Okay, so you have um, so in one day they just use 10, let's say 10 boxes of flour. In 2 days they use 20 boxes of flour, and so on and so forth. Okay? So what we need to find first, remember the formula. So it's xi minus x bar squared divided by n minus 1. But this is a frequency series. So frequency series is nothing but the summary of the data. So in fact, what we have is we have 10, 20, sorry, 20, 20, and then you have 350s, 50, 50, 50, okay? And then you have 70, 70, and then you have 8, and you have 100, okay? So in fact, this is a compact form of this data. So you can calculate the average and the standard deviation of this data, okay? Sorry, you can calculate the standard deviation of this data just similar to the way that you calculated for this one. So first we need to find the average, right? So how to find the average, remember, we will do 10 times 1 okay, plus 20 times 2 plus 50 times 3, 7 times 2, 8 times 1, 100 times 1, sum them up and divide it by right, the number of observations here. Okay, so it will be 10, not 20, but 40. This is 150. This is 140, 80, and 100. You just sum them up. Okay. Okay, so that's equal to, let's see, 520 and divide it by 10. So that's equal to my x bar. So x bar is equal to 52. Okay, great. Or remember, another way is, let's say these are the, let's find the proportions. So this is 1 divided by 10, which is 0.1. and 2 divided by 10, 0.2, 0.3, 0.2, 0.1, and 0.1. So what you do is just multiply 10 with 0.1, okay? So 10 by 0.1, that's equal to what? That's equal to, sorry, 1. And this is what? This is 4, right? This is 0.3 times 50, so that's equal to 15, right? And so this is equal to 40, that's equal to 8, and you have 10. If you sum them up, that's equal to what? That's equal to 52, okay? Exactly the same thing, right? Again, please remember this, how we find the expected, the average, the mean, by using the proportions, and we will talk about this later. So now, how to find the variation, okay? How to find the variation. So in order to find the variation, what you should do is, so just look at this one, okay? Just look at this one. We sum the square difference of all of the data. So let's say this is xi minus x bar, okay? So let's write this. So this is 10 minus 52, that's equal to minus 42, 20 minus 52, that's equal to minus 32, 50 minus 52, that's equal to minus 2, 70 minus 22, that's equal to 18, 80 minus 52, that's equal to 28, 100 minus 52, that's equal to 48, okay? And then what you can do is you can take the square, right? Take the square, and this is minus 42 square, that's a big number, right? Take the square of them. But the thing is that, well, we won't sum them directly because this is a frequency table, okay? This is a frequency table. So what you have is, you have so you have minus 42 squares, and this is the frequency of this one. So you have one many minus 42 squares. You have too many what? Minus 32 squares. Okay. So what you will do is you will have 1 times minus 42 squared plus what? Plus 2 times minus 32 squared, then 3 times minus 2 squared, and then what? 2 times what? 18 squared, okay? Dot, like this. You will sum them up, right? You will sum them up, and then again divide it by what? Divide it by um, not n but n minus 1, okay? Divided by not n but n minus 1, okay? In order to find the variation, okay? Right? Great. Um, so this is the total variation, okay? The total variation. In order to find the sample variation, we will divide it by n minus 1. So this is 60 divided by 9, and well, you can just calculate its value. Okay. So what is the difference between high and low variance of a data? Just look at these two different histograms. We will talk about the histograms, but so you see, um, this is the same amount of data. If I'm not wrong, there are 100 many observations here. Both of them have the same average, which is 60, okay, which is 60, which is 60. As you see, this data is much more concentrated around 60, okay? But this data, well, it's much more dispersed around 60. So there are six many observations, which is at 35, and six many observations, which is at 40, and one observation, which is at 95. But when you look at this one, well, there is no observations at 35, 40, or 45. Okay. So this is in fact what is a high variance, and uh, what does a high variance, what does a data with high variance look like, and the data with low variance look like? Okay.